All right, so 8.2 is going to look at the other trigonometric functions, so like tangent and then the reciprocal functions. So if we look at this picture here, tangent looks slightly different. It's not continuous. It has multiple pieces. And that's because tangent is sine over cosine, and sometimes cosine equals 0. You can't divide by 0, so that's where we get these asymptotes. So if you remember from the rational graphs, asymptotes are the lines that it approaches and gets closer and closer to but never touches. So those are really when cosine equals 0. So you're going to see that in general, they're like pi over 2, 3 pi over 2. You don't need to know that in order to do the graphing. That's just the general. And this one, the range is negative infinity to infinity because it goes up and down forever. Notice the period of tangent is only pi. So it's not 2 pi, it's pi. So when we're finding the period, we're going to be doing pi divided by instead of 2 pi divided by. That's the biggest difference there. And then your stretch factor, if you take the period and divide it by 4, that's the y value where you'll go up that height. I'll kind of show you what that means, but that's where these come from. So those are your notes on tangent. Now let's do one. So same thing. We're going to find our stretch factor. It's not an amplitude because there's no max and min, but we find it the same way. So the stretch factor is the absolute value of A. So absolute value of 0.5 is 0.5. Then we find our period. So this time we're going to do pi divided by pi over 2, which is pi times 2 over pi, which ends up being 2 pi over pi, or 2. So since our period's 2, I'm going to change our numbers. So I'm going to go 1, 2, 3, 4, like that. The way the period works for tangent is you're going to divide that in half. So we're going to have 1 unit on each side. So that means like here you have a midpoint and then you go to the right and the left. So we're going to have 1 unit from each side of the origin. Then we go back up and we do our period is 2. 2 divided by 4 is 1/2. So we're going to use that to apply our stretch factor. I'll show that in a second. And then there's no adding and subtracting, so there's no phase shift, and there's no vertical shift. So that means our midline is still at 0, and our center is the origin. So I'm going to put that dot right on the origin. And then we said it's 1 unit on each side. So our period is going to be 1 unit above, 1 unit below. And then at a half, so right here, a half, we're going to go up to 0.5. And then in the reverse, we go down 0.5. So those are the 3 points we're going to use to draw our tangent curve. And that would just repeat. Okay, so if I copied this, right, because it's periodic, it's going to do that. And then it's going to do that again. And it's going to keep doing that forever. It just has all those breaks. All right. Oops, undo. So let's look at this next one. So our stretch factor is the absolute value of 3, which is 3. Our period is going to be pi divided by pi over 6, which is pi times 6 over pi, which ends up being 6. So again, I'm going to change these to 1, 2, 3, 4, -1, -2, -3, -4. The 6 tells us we're going to go 3 units on each side. And then if I do 6 divided by 4, I get 1.5. So that's going to tell us where to do our stretch factor. So there's no phase shift. There's no vertical shift, so we're still at 0, and our middle is still at the origin. Now we need to go 3 units on each side. Okay. From the origin, we're going to go over 1.5 and up 3. And then the same thing in the other direction, but down. That gives us our points. And then we draw. And essentially it just raises, kind of flattens out, and then switches direction. It's not always easy to draw, but it's okay as long as you get that general gist of it. All right, now let's combine all of the things. So same as before, if we have a phase shift and a period shift, we have to factor out that pi. Now we can do everything else. So our amplitude is going to be the absolute value of 2, which is 2. This negative just tells us we're going to go down instead of up. Our period is pi divided by pi, which is 1. So I'm going to change these. 1, 2, 3, 4. And that means we're going to go a half on each side. And then 1 divided by 4 is 1/4. So I'm going to use that for my amplitude. My phase shift is left 1. And my vertical shift is down 1. So we'll start with the vertical shift. That down 1 means that's where I'm going to be plotting my center point. And the phase shift, meaning left 1, so instead of the origin, I'm going to go left 1. Because we said those were like that. Now we have a half on each side. So from there, a half and a half is going to be our shape. And then we're going to go 1/4. So in between there, down 2. And the opposite in the other direction. And now we kind of try to draw our shape. So that's 1 period. And we could just keep doing that over and over and over again if we wanted to. All right, so why don't you go ahead and try the other one. Pause the video, see how you do. Amplitude is 3. It's positive, so we're going to go up. There's nothing in front of the x, so that means our period is going to be pi. So I'm going to leave these symbols, which means we're going to have pi over 2 on each side. And pi divided by 4 is pi over 4. Our phase shift is left pi. And our vertical shift is up 1. So we'll start by drawing our midline. Our normal tangent center would be on the y-axis, but we need to go left pi. So go down to negative pi. From there, we do pi over 2 on each side. And then we go over pi over 4. Up 3, so that's 1 dot up 3, 1 dot down 3, and there's our 1 phase. So that's how tangent works. Now let's look at finding the formula. So start with the same thing. Let's find our midline or our vertical shift. So that's still going to be 0 on this one. So we don't have to add anything. And then, so we're not going to add anything over there. Now let's find our period. So we go from -4 to 4. So that's 8. So if our period is 8, we have to do pi divided by 8, which is pi over 8. So that's going to be what I put in my parentheses there. 8 divided by 4 is 2. So from that center, if I go over 2, How far do I go up? Well, I went up 2, so that means my amplitude is 2. And because I went up, it's positive. And then that point still sits on the origin, so we don't have a shift at all. So we can just leave it as pi over 8 times x. All right, let's look at this one. So our midline is still 0. So we know we're not adding or subtracting anything. Our period goes from negative pi over 4 to positive pi over 4. So that's half. So it's our period is pi over 2. So if we do pi divided by pi over 2, which would be pi times 2 over pi. So that's going to be 2. So that's what I need to put here in front of the x. Pi over 2 divided by 4 is pi over 8. So it's like halfway in between that. So if I go halfway, we go up to about 5. This one's hard to tell on here. But so that means our amplitude is 5. So I'm going to stick that in front. And then our center point is at the origin. So that's the equation. All right. So now we have the reciprocal functions. Okay, the reciprocal functions are 1 over. So this graph right here is cosine. 1 divided by cosine means everywhere where cosine 0 is going to become an asymptote. So I'm going to draw asymptotes at every single one of those x-intercepts. And then when we're doing an inverse, or reciprocal, sorry, decreasing because it becomes increasing. X-intercepts become asymptotes, we just do that. Maxes becomes mins. So the top of this bump is going to be a minimum, so our graph's going to go up. The bottom is going to be a maximum. So the secant graph are those pink lines. So if you know how to draw the cosine, the secant you just draw after. Okay, so secant goes with cosine. So we're going to graph it just like a cosine graph. Our amplitude is going to be 2.5, and it's positive, so we go max to max. Our period is 0.4, so 2 pi divided by 0.4, which is going to give us 5 pi. So I'm going to change this just so I have room. Pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. There's no vertical or horizontal shifts, so our period's going to go from 0 to 5 pi. And then cosine goes max to max, so our max is 2.5. In the middle, our minimum would be 2.5. And then we kind of cross like that. So the blue would be the cosine curve. So for the secant, I'm going to get rid of this just to help you see a little bit. So for the secant, our zeros become our asymptotes. It's around here. And then the curves flip. So this points that way. This points that way. And that would be one period of the curve, which we could just repeat over and over again in both directions. All right, so if we look at the next one, secant tells us cosine. So our amplitude is going to be positive 3. We're just going to go min to min. And then our period is going to be 2 pi divided by 2, so we get pi. So that means our graph's going to go from 0 to pi. Our minimum is at 3, so we're going to go -3 to -3, top, middle. There's our cosine. Now, make this thicker. How about that? So now these are our new asymptotes. And we flip the blue curves. And again, you can put that on your calculator. If you wanted to graph that on the calculator, secant is cosine. So we would do -3 and then parentheses 1 divided by cosine of 2x. And see, we just get those curves. Cosecant is the same exact thing. We're just doing the sine graph. So here, our amplitude is 2. We go up first. Our period is 2 pi divided by pi over 2. So 2 pi times 2 over pi, so we get 4. So I'm going to change these 1, 2, 3, 4. And our vertical shift is up 1, so we're going to have a new midline. But we don't have a phase shift. Vertical shift was up 1. So we're still going to, sine starts at the origin. We just go up 1. End at 4. We have our middle. Amplitude is up 2 and down 2. So there's our sine curve. Anywhere, now we're going to use that midline for our asymptotes. So anywhere where it touches the midline becomes an asymptote. And then we flip the curve. So there is 1 period of cosecant. All right, let's do this one. Amplitude, absolute value of -0.5. So it's -0.5, or it's 0.5, but we're going to go down first. Down first. Our period, we're going to divide by pi. So 2 pi divided by pi is 2. So I'm going to change these 1, 2, 3, 4. Our phase shift is pi over 2. And then our vertical shift is down 2. 2 pi divided by pi is 2. What did I do there? No idea. Okay. So our phase shift is plus pi over 2. So pi divided by 2 is like 1.5-ish. So I don't really know what's helpful. Yeah, well, 1.5. Usually you will have, they'll either both have pi's or they both won't. But if our phase shift is about 1.5, instead of at 0, we're going to go to 1.5. And then our vertical shift was down 2. So we're going to take that point and put it here. We know our period is 2. So from there, we would go 1, 2. So that's the end of our period. That's the middle of our period. And we're going down first, and we're going down a half. So in between those two pink dots, we go down and up. So that's our sine curve. Now we're going to turn the dots into asymptotes and flip the curves. So secant and cosecant aren't bad if you know how to do your tan or your sine and cosine. The last part of this section is the cotangent. So same idea, it's just the flip of tangent. So amplitude is 3. Period is pi divided by 4. So pi over 4. There's no shift. So for tangent, we would start at 0. Our period's pi over 4. So that's pi over 8 on each side. So we're going to go, oh my Lord, okay. So pi divided by 4 would be, this would be the whole period. So it's like half of that. So it's going to be in between these two tiny little things. And then halfway between there, we're going to go up 3. Halfway between there, we're going to go down 3. And then we would connect it. So that's really hard to draw on a small thing. So I'm going to change the graph so that this is pi over 4, actually. And make the whole thing. So this is pi over 4. So this would be pi over 2. And then negative pi over 4, negative pi over 2. You can make the scales whatever you want. So we're still going to, If I put them in the right place, that's helpful. Negative pi over 4. Okay, so we're still going to put the middle here. And then halfway through, we're going to go up 3 and down 3. So this would be the tangent curve. Okay. Now, the way this works is the asymptotes, those orange lines, become the new intercepts. So these become our new points. And then the intercepts become the new asymptote. So it would also be 4 in that direction. And then our graph's going to be the opposite shape. So like these are still going to match, but now we're just going to go down instead of up. So these are still going to match. We're just going to go down instead of up. So that's cotangent. All right, so one more in this section. Amplitude is 2. We're going to divide out the pi over 8. So we would get x minus 4. Period is pi divided by pi over 8, which gives us 8. So I'm going to change 1, 2, 3, 4, 5, 6, 7, 8. And then we shifted right 4 and down 2. So our midline's here. And then instead of starting at 0, we're going to go right 4. That 8 tells us we have 4 on each side. 8 divided by 4 is 2. So from that point, we're going to go up 2 over 2, down 2 over 2. So there's our tangent graph. And I'm just going to repeat that over here. Literally looks just like that. Now, wherever the asymptote is becomes an intercept. And wherever the intercept is becomes an asymptote. And then we just connect the points in reverse. So these 3 points just become the new ones. So this would go like that, and so on. So that is section 8.2.